I'm going to talk about integrating harmonic functions, and we'll see that they have this nice mean value property or average value property, which basically says if you integrate around a circle, and this really is about circles, right? W plus R e to the it is a circle with center W. Here the center is going to be 3. I'm going to do 2 examples in any radius. If you add up all the different values along the path and divide by 1 over 2 pi, which is the number of radians, that's going to be equal to the value just right at the center. So the value at the center is going to represent the average value along the entire path. This only works for harmonic functions. Well, you can only be sure it's going to work for harmonic functions anyway. And let me show you kind of how to think about this with 2 examples. So I'm going to take the easiest non-trivial harmonic function I can think of, which is u of x plus iy equals x. And then if you do some scratch work, u of xx plus u of yy, what is that? U of xx, u of x is 1, u of xx is 0, u of yy is pretty clearly going to be 0. Oh, so this is indeed harmonic. I'm centered at 0, which means that when I compute this integral, I'd better get the x value there, 0. I'd better get 0 when I compute this integral. And so I am going to compute this integral. And the way I'd set it up is 2 pi times the integral from 0 to 2 pi. The x value of anything along the circle is just going to be 2 times cosine t. So that's the u part, and then dt. So you can probably maybe see how this integral is going to equal 0. But let me explain to you geometrically how I might know. If I take any point here, say x plus iy, when I take the function value, I just basically say I don't care about the iy. I'm just going to add up this x value here. So I'm going to have a sum, and I'm going to add up the x value. But over here, I'm going to have a corresponding negative x plus iy. Again, the value only cares about the x value, so I cancel them out. When I add up these 2 values, I'm going to get them to cancel out and give me 0. And that's going to be true anywhere along the line. Anything on the left half has a corresponding piece on the right half that's going to cancel out with it. So I'm going to add up all the different values here and multiply by the length, which is basically 2 pi r. And then when you divide out by 2 pi to average out the number of radians, you're going to get a whole bunch of cancellation, and things are going to work out very nicely. So let's just actually compute this. You're going to see that things are going to cancel out, that things have to have canceled out. Right? Oh, this is just going to be 2 sine t from 2 pi to 0. Oh, that's clearly sine 2 pi is going to be 0, and sine of 0 is going to be 0 equals 0, which most importantly equals u of 0 equals u of w. Great. But maybe that's just a coincidence because we centered around the origin. No. Let's look and see what happens here. Here I'm centering in around 3. I'm going to show you that here u of w, which is this piece over here, equals u of 3. And the x value for 3, which is 3 plus 0y, is going to be equal to 3. The average value around this interval is 3. And before I calculate it, let me show you why you should believe that. If I take a point here, I can think of it, oh, this is just 3 plus a little delta x plus iy. If I take the function value, it says don't care about anything having to do with the imaginary part. But this point here is going to be 3 minus that same value plus iy, and then we don't care about the iy. If I add these up and average them, I'm going to get 3, because the negative x and the negative delta x and the plus delta x are going to cancel out. So if I do this over the entire thing and divide by the length of the circle, roughly, I'm just going to end up with the value 3. And let's see exactly how that shakes out. 1 over 2 pi times the integral from 0 to 2 pi. Now the x value is going to be 3 plus 2 cosine t dt. Oh, that's going to be 1 over 2 pi times 3t from 2 pi to 0 plus 2 sine t from 2 pi to 0. Oh, well, that's going to be 1 over 2 pi times 6 pi, oh, which equals 3, which equals u of 3, which equals u of w. Notice the r kind of gets lost in the shuffle because I get all this cancellation around here. So you should expect that that's going to happen. So the r doesn't really matter, which is why you don't need an r down there. Bye.